And today's topic, I think, is on functional interfaces, right? We saw interfaces yesterday, right? And so, what is an interface? I think what goes in an interface? Yeah. Okay. So, what are the members in an interface, right? So, it would be something like this, right? You will have modifiers, okay, while defining an interface. Fine. So, for example, you might say abstract is a default modifier anyway, right? But you might be saying it's a public interface or not, something like that. Then use the keyword interface. Okay. So then there is the name of the interface. Okay. Optional part would be extends and list of interfaces. Okay. Okay. So here's the body of the interface. In the body of the interface, what are the members we can have? We can have fine variables. Okay. Okay. These variables will be static and final. Okay. Even if it's not mentioned as static and final. Okay. Fine. Okay. Then it can have methods. Okay. So what kind of methods can be there? By default. So if you don't have a modifier for these methods, by default it would be, okay, and I should say methods default modifiers are public and abstract. Okay, default modifiers are public and abstract, and other modifiers specifically mentioned. Fine. So other modifiers, so by default, okay, other methods, I'll just put it as other, for other methods, okay, default access is public. Okay, fine, default access is public. Okay, okay, fine, and then we'll mention the rest. Okay, so default access would be public, and the, okay, what are the other modifiers for other methods, right? Other modifiers which are allowed. We can use static methods. Okay, fine. Static methods, default access would be public, right? Can also be declared private. Okay. In interface, your static method could also be, you could have a private static method as well. Okay, fine. Other kind of method, well, so by default they are abstract, right? If you don't mention, they would be abstract. You may mention abstract. Okay, fine. But if you want to write an implementation, it is allowed from Java 8 onwards. Okay, but for such thing you have to use a modifier called default. Okay, fine. So default methods, again, their access would be public by default, but can also be private. Fine. So these are the various kinds of members which go in a, fine. There's no question of any constructors. and no initializer block, no static block. Okay. Of course, what is remaining here other than this is you can have nested types. Final will be with the variables. Right? So variables will be static and final. Fine, clear? Fine, for interface, rules are like this. Fine, members of interface. Oh, these are the members of an interface. Okay. Fine. As an example of an interface, yeah. Okay. Now, thanks. Now let's look at another aspect of the interface. We have interfaces from Java 8 onwards. We have a concept of a functional interface. Okay, so it's this interface only, function interface. What is a function interface? Okay, right. So a simple definition would be, okay, functional interface is an interface with single abstract method. Okay, so if you have an interface which has only one abstract method, yeah, other kind of methods can be there, other members, static variables can be there, but as far as abstract method is concerned, there's only one abstract method. Okay, then such an interface will be a function interface. So we had interfaces all the time, right? And many of those were also there present which would have only one abstract method. So all such methods, all such interfaces qualify as a function interface. Okay, and only one slight modification to this is, so when we say single abstract method, and what do we mean by single abstract method here is, okay, we have to ignore some of the abstract methods, ignore abstract methods. So when you say how many abstract methods are there, oh, then you ignore the abstract methods, right, which are public in the object class. Right? So any public method of the object class which is declared as abstract in an interface, oh, that will have to be ignored. Okay. See, for example, someone might have an interface, so I'll say, oh, I have a public interface. Okay, function 1, fine, and okay, I have an interface called function 1, and I'm saying, okay, let's have a public method. And even if you don't declare, it would still be public, whose return type is void, takes a parameter, okay, let's call this as a method 1, or maybe lowercase, I'll say function 1, okay, takes parameters as, it's a function, so maybe I might like to return a value from this int, takes parameter as maybe a string, okay, and another integer a, okay, maybe something like this. And so this is a abstract method, this is a function interface. So function 1 is a function interface because it has only one abstract method. You may be having default methods, you may be having static methods, you may be having any number of public and static final variables. Okay, it would still remain a function interface. Okay, but if someone says, okay, let me have a public string, toString, and says, okay, oh, this is a public method of the object class. right? So this still remains a function interface. Fine. This is still a function interface because the abstract method counts. If someone says how many abstract methods in this interface, we see there are 2 abstract methods. Okay, but the second one should not be counted because it's a public method of the object class. Okay, so this is to be ignored. Fine, clear? Okay, so what is a function interface? Those interfaces where we have only one abstract method, right? And when I'm saying one abstract method, we would not count the public method of the object class. Right? If such a method is declared as abstract, as is the case here, right, then we don't count this as an abstract method here. Okay, so yeah, what is the use of this? And what is the use of a function interface? Okay, so functional interface have been introduced from Java 8 to allow us to create function objects. It allows us to create function objects. Okay, see, what does this interface have? Of course, the name is function1. Okay, and maybe I might change the method name so that you don't get confused with this. Okay, so I'll say some function. Yeah. Okay, I'll just change the method name to some function. Okay, so we have a function interface. We are saying, okay, it is called function1, and it has a abstract method called some function, right, which takes two parameters and returns a value. Okay, so that's my abstract method here. Okay, so now the difference between functional interface and the other interfaces is, for functional interfaces we can create objects. Okay, we can create objects which are the function objects, but anyway they are not objects of the function one. They would be object of a subtype of a function one. We understand interfaces, you can't create objects. Okay, you can't be creating objects of a interface. Okay, fine. So, but yes, there is a syntax which we call as a lambda expression, which can be used for creating objects. Okay, so let's see how we can use this to create an object. Okay, so since this has a method, now what is, so I can do something like this. I can say, oh, I have the function one. Let's give a variable name. Let's say f1 equals, and now the syntax for a lambda expression. What is the syntax for a lambda expression? A input parameter list. We'll say, okay, I have a function, so now I'm defining a function. To define a function, what do we give? You have to use a function name? No, we don't need a function name here. Okay, right? We have a variable which will have the function. We have a f1 which will have that function object. Okay, so what else was needed? The input parameters. Okay, so this will have two input parameters, int a. Okay, we use a lambda operator to make it clear that this is a function object. Okay, we are creating an object for a function. Okay, and then yeah, you have to write the body of the function. Okay, right? Okay, so here's the body of the function, and what the body of the function is having? It's having the implementation of the method some function. See, the name of the method doesn't come into picture for the creator of the function object. He's creating a function object, okay, for some function. So you have your own implementation and you have your steps here, okay. Okay, but at the end you will have to be returning some integer value because that's what is expected with some function. Okay. Okay, int expression rather than saying value, some integer expression must be there. So this is the syntax for a lambda expression. So if you see how it goes about is like this. From this left hand side, the type is function 1. Right? When it finds the type is function 1, okay, right, it will know that on the right hand side it has to be of this type only or some subtype of this. Okay, when you put that lambda operator, it realizes that this is nothing but a implementation of a function for whatever is the type of the expression here. The type is function 1. Okay, so this function 1 has only one abstract method, right? So this obviously is the implementation of that method. Here it says, okay, so this has to comply with the implementation of the abstract method. So you are writing straight away the implementation of an abstract method. Right? See, another thing to note here is what happens when someone writes this kind of a statement, a lambda expression. You have, let's say you have written something like this, system.out.println s, or maybe s equal to plus s, okay, and maybe plus, maybe you also want to say a equal to plus a. Right? So you want to print the values of s and a, and there might be some other code here, okay, which helps you to compute a integer expression and you are returning it. Okay, so when I execute this statement, fine, when this is a statement, right, which is an assignment statement where the right hand side is a lambda expression, we're assigning to f1, right? So my question here is, will there be an output? Will there be an output when this statement is executed? Will it have that system.out.println? Or okay, let me put one more additional system.out.println. Okay. Okay, I'm writing something like this. Created F1. So do you think created F1 is going to be printed when the statement here is executed? Yeah. What is this right hand side doing for us? Right hand side of the assignment, what is it doing for us? It's creating the object. It's not executing it. You define a function and then someone will have to call it, right? So this step is not going to print anything. It's not about executing this function. The function doesn't get executed. The function is getting created. Is different from function getting executed. Okay. Oh, how will this function be executed? Yeah. F1 dot. Yeah, you're correct. Call F1 dot what? Oh, how will you execute it? F1 dot. Yeah, F1. What's the type of F1? Function 1. What operations available for function 1? Some method? Some function. So you'll have to say some function. Okay, and give a string here. Okay, give some value. Fine. Whenever someone is doing this, right, after having created some place, someone is going to use this. That's the way to use a function. So this is creating the object of a function and making it available from a variable called f1. Anytime onwards, you use f1 dot, and oh, that's the abstract method, right? For which the implementation is given with the lambda expression. So what is lambda expression? It is nothing but an implementation of the abstract method, and that single abstract method of a functional interface. And we have a single abstract method of a function interface. That's what a lambda expression is. Okay, fine. Want to try this out? Fine. Okay, now what I'll do is I'll show it on J shell. Okay, because there are a few other things we'll try with this. Okay. Okay, so let's come to J shell and let's see how the things are working for us. And we'll, since we know about, I'll use some of the reflection API so that we can analyze it further. Okay. 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 And here, so first part is, yes, we want to have a interface called function1. So let's define public interface function1. Okay. And this will have a public method returns int. Name of the method is some function. Parameter is a string s int a. Okay, fine. So that's the abstract method. Fine. We want to include the other abstract method from the object class. We can. Okay. Fine. So that's the created the interface called function1. Okay. Now let's use it for a lambda expression. So I'll say, okay, we have the function1. Okay, and f1 is the variable equals, and let's have something like this, right? Okay, let me see. Oh, sorry. Here we are writing the implementation of the function. Let's say, achha, we have already, no, we have, yeah. Here we have, so string, you can use your own parameter name. Okay, this is nothing to do with that parameter name there. Okay, s and a, you can use a different name here. Okay, str comma int x, yeah, and okay, let's use system dot println. created F1, okay, and system.out.println, we have str, okay, equal to plus str, okay, plus we have a x equal to, yeah, plus x, okay, and let's return the value of x itself. Let's say we just return it, right? And right? So here, yeah, here put the semicolon to end the assignment. Okay, so we have created a function, and you can see what it is showing to us. It has created a lambda expression. Okay, here it has created just a lambda expression, and now, okay, now how do I use this? So at this point, there was no output when we executed this statement. If you want the output, what we should be doing, f1.sum function, okay, and pass the parameters. Okay, yeah, you can pass different parameters, right? f1.sum function. So through f1, you are able to execute that function. Function was defined, made available in a variable. F1 is that variable, and then later I can change that function. Okay, I can say, okay, let f1 have a different function now. It will have the function, f1 is of type function1. So the lambda expression has to match the signature of function1, some method. It has to match the signature of some function here. Okay, so yeah, here I might have a different output here. Okay, right? So okay, okay, fine, and maybe return x plus 100. Okay. So I have a different implementation of that function, but the variable is still the same. Okay, and I'll be calling that, yeah, okay, we had that, sorry, yeah, here, fine, let's call it again, and this time, yeah, it's printing it, right, according to the new function. So that earlier statement was replacing that function available from f1 with a new implementation. Fine, the variable is still f1. You are calling some function from f1. Okay, fine. See, clear on this now? See, we have a, we had something, it's something like this. What is the lambda expression doing for us? So if you got a variable, okay, so this was f1, okay, and it was made to refer to an object which we say this is a function object. For which function? The function was, this is a function object for implementation of some function which takes two parameters and returns an integer value. So this is just a function object. So when we use a lambda expression, the function is not executed, it is actually created. Okay, use a lambda expression, again make an assignment to f1. So f1 can refer to, instead of this, I will have a different function object which has its own separate implementation. Okay, how to use that function? So we use it from f1 dot some function, and that sum function needs two inputs. Give the two inputs. Fine. It is returning an int. You might say int, fine, O equals something like this. Yeah, you can do something like this. It's returning an integer value. Fine. So here is function as an object, right? Here, see that lambda expression is nothing but a function, and we have an object of the function available from a variable. Right? But such thing is only allowed with a functional interface. If we have a functional interface, yes, then there is no ambiguity about which method is being implemented by the lambda expression. So of course it derives the lambda expression which you write. Just by looking at the lambda expression, you do not know the type. Okay, the type is inferred from the left hand side, from the context where it has been used. Okay, fine. Just a quick look at another aspect. I might be using, so this is an object, right? Now we say, okay, whenever we can't create object of an interface, right? Till now, whatever objects we have created have been created from for some class. Yeah? There has to be a class definition available, right? For that class also a class definition, a dot class file is needed. There's no dot class file here. Fine. If I'm going to compile this kind of a lambda expression code, that lambda expression is basically another class definition, which is implementing the interface called some function, right? Function 1. Fine. We have the interface called function 1. Okay, fine. Now we have that object f1. Okay, so I'm just showing you something here. Okay, fine, which will be related to what is f1 here. Okay, so we have got f1 object. Okay, let's see what is f1 dot get class. So there has to be a class object for it, right? Is there an object? So what is f1 dot get class? Dot, let's see the name. Yeah, this is the name of that function. There is a class, right? Okay, so it has created its own internal class name. Okay, understand there is not we do not have a dot class file for this. Okay, it's not a pre-compiled thing. Okay, at runtime, as it is executing, it's executing the lambda expression, and then on the fly it's creating a class object. Okay, so we do have a class object which is available by saying f1.getClass.
But there is no f1.class, you're saying?
There's see, what is the name of that? $lambda $20 slash this, right? So
Okay.
So there's a internally there is a class object.
Name.
Class object. Okay.
Okay.
Fine. Let's see what is the superclass of that. So from this, let's say get superclass
name
dot get name. What's a superclass?
Oh.
Okay, superclass is object. And let's see what is the
type.
What's the interface it is implementing? Get interfaces, yeah. Okay, so we can say, okay, fine. Let's see. So this will anyway, it has created a array. What it has given us? Array of class object. Fine. Object of that class is representing a type. So there's only one interface which it is implementing. Okay, there's only one interface which it is implementing. Okay, and if you look at that, so it's available through the variable called $8. Okay, so $8 is an array of class. Fine. So $8, I can use $8 of 0. That's a class object. Okay, so $8.0. So this is a class object dot get name. Let's see the name. That name is function. So it's implementing function. It's a class, and it's some kind of a class which extends from object and implements the function one. So on the fly, it has created this definition and is available. Now, another aspect of this, there is also a method. Since we have this, right? This was fine. We have that f1.get class dot. There is one more method which I'm going to use. Okay, is synthetic. This is a synthetic class because it has been created. There's no class file for this. Okay, so it's known as a synthetic class. So is synthetic is true. Okay, see, for example, we have the class called string, right? So if I say string dot class, so that's a class object for the string dot is synthetic. No, that's not synthetic. It's created from a class file, right? But that one has been created on the fly. Okay, and so this is a synthetic class. It's an object of a synthetic class.
It is just faster execution, is that the advantage?
No, it's because with lambda expression, you would not be having so many class files created. Okay. Okay. Otherwise, what was see? Otherwise, what was the way out? Yeah. What was the way out? Otherwise, if we didn't have the lambda expressions, then what would have been the way out?
You have to make a class name.
Yeah, you have to say there is a class which implements function 1, and then you say, okay, let me define that by saying public write the implementation for the override the sum function, right? Override that sum function method, have a class which implements function 1, override the sum function method, fine, and then create the object of that. Fine. So that part, defining a separate class like that, is avoided with the help of a lambda expression, because in such a case, yes, it's a pre-compiled class definition which you are having. Okay, here when the lambda expression is being executed, the statement which has the lambda expression that is being executed, at that time the class definition is created for us. Okay, the class object comes into picture, is getting created there, and it's not a preloaded class.
On the fly.
Okay, fine. So dynamically created. Okay, so each place you have a lambda expression, yes, there is a class definition which is being created. It's a synthetic class, and it's the implementation of that functional interface. So lambda expression is the implementation of the functional interface. Okay, so lambda expression cannot be used for other interfaces. It's only for those interfaces which have a single abstract method. Okay, fine. This feature is from Java 8 and onwards. Okay, lambda expressions. So what is lambda expression? It's nothing but a function. Okay, fine. Now, yeah, we want to use it. Fine. And we would like to use this function interface. Okay, so for our exercise which we have, right, we have this exercise for account class. Yeah, we have created a subclass called current account. Fine. So in this subclass called current account, we are having, what's the difference? It uses a penalty. Fine. It uses a penalty whenever there is a withdrawal which takes it below the balance becomes less than minimum balance. Okay, that penalty is a fixed value. Instead of having it as a fixed value, can we have it as a function? Can we have penalty being computed as a function of the balance which you have and the minimum balance, two inputs? Give me the balance, let me know what's the minimum balance required, and I'll compute what should be the penalty amount. Okay, fine. So we would like to have penalty as a function and not as a fixed value. Currently, we have said, penalty amount is fixed and it's going to be 100. Okay, fine. And also just to introduce some more make it more dynamic kind of a current account thing. Okay, what we can do is let there be a different penalty function being allowed for different current account objects. So we would not keep it static, but let's make it as an instance variable. Okay, fine. So whenever a current account is created, some penalty function is assigned to it. Okay, some kind of a penalty function is also getting assigned to it. Okay, we can have some default, by default, yes, this is the penalty function which should be used. Fine. And otherwise, we can add a method to set a different penalty function. Okay, so for example, we have here, let's try to define some interaction here for the current account object. So additional things for current account. Okay, so current account object is inheriting from account. It gets the instance variables for length, width, and sorry, not length, sorry, it's account number, name, and balance. Fine. Fine, we have the instance variable. So even current account has a account number, name, and balance. Now, if it's a current account, right? Okay, we are saying a current account will have a reference to a penalty function. So here is a function where there will be two inputs. Okay, fine. Here is a penalty function where there will be two inputs, and it should give me the computed penalty. Okay, so when a current account object is there, yes, we will have some penalty function. Fine, and we can have a different penalty function being assigned to a different object. So, or maybe we would like to say, so yeah, what will be the type of the function? Let's call it as, so our functional interface can be called as penalty. Okay, let's have an interface called penalty. Fine, and what should be the abstract method for this? Yeah, we want it as a function type, right? Penalty is a function type. If it's a function type, it would have a method, so which is a method like this, right? So it's a public and abstract method, returns long. The penalty will be of type long. Okay, let's give the method name as compute with two parameters. Fine. First parameter can be long. Okay, this will be for what is the balance. Okay, another long for what's the minimum balance needed. Right? Okay, so we can add a abstract method. Fine, we have this as our penalty function. Okay, that's the abstract method which has to be. So someone could then have, okay, so when I have an so we can now have a method here in the current account. So especially now specific to the current account, we can have a method by which initially, yes, there will be some default function which we assign. Penalty function can be there, okay, which can always compute to the value 100. Okay, fine. And a second one would be something a method for the now what we want here, a method for the current account. So we can say, okay, let's have a method called set penalty, where a penalty is taken as a parameter. Okay, this is nothing but your penalty function. So we can have a method in the current account called set penalty, by which we should be able to change the penalty function for a given current account object. Okay, fine. So fine, the idea is clear. We want a functional interface by the name penalty. We will have a method in that called compute, fine, takes two inputs and returns a computed penalty. Inputs are what is the balance and what's the minimum balance. Okay, fine. And we add an instance variable in the current account. It's only for current account, so it's not affecting the account. Right? So in the current account, we have another instance variable. The type is penalty. So update the current account class to have an additional instance variable called penalty. It will be private. Add a method called set penalty, right, by which you should be able to set a penalty. Okay, you could have something like this. So within the current account class, what we should be having is we should be doing a okay. So in the current account, yes, you will have a now this entry is in the current account, instance variable like this, private penalty. Maybe the variable name is called penalty, equal to, we may do an assignment, so we keep a default value for it. Okay, equal to, yeah, what will I write here? Equal to, then the type here is penalty, which is a functional interface type, and therefore I should be able to use a lambda expression here. After equal to, I'll put a lambda expression. What's a lambda expression? oh, I forgot to tell you that when we write a lambda expression, it's not necessary to declare the type for the parameter variables, right? Because it will know about it. It can be inferred from the left hand side. It knows the type is penalty, and therefore it knows the compiler will be able to find out what are the types of the parameters. So you can straight away use even parameter name instead of saying long balance and long minimum balance. Fine, when writing a lambda expression, it's not necessary to mention the types for the parameters. So you can just say balance comma minimum balance. Okay, and write a lambda expression, right? And what will it do? Oh, it has to compute. Okay, so here we have to be careful that yes, even if someone is passing trying to use the function where it is not applicable, we should still be computing and saying, oh, it's 0. Okay, if the balance happens to be greater than the minimum balance, oh, we should have the value as 0. Okay, fine. So you can say, okay, in this case, yes, the return, so you can say return. Okay, if you're putting in the part. Another aspect of this is when you write a lambda expression, if it's a single statement, which happens to be there in the block, you don't need the block. Okay, fine. The block is not needed, and if it's a return statement, don't mention return. Just put the expression to be returned. Okay, I think I'll put this in the text so that it can be slightly better. I'll put it in the text here. See, what is needed is something like this. Okay, so what is needed is current account to have a, so within the public class, okay, and we have the other things here, extends account and all that. Okay, fine. We already have the class doing certain things, fine. So we want an additional private variable by the type penalty. Okay, let's have fine equal to, and now I don't need to specify the types of the parameter. It's not necessary. So I'll say it is balance comma min balance. Okay, and since it's only a single statement, and I'll say okay, I don't put even the return keyword, but straight away put the expression. What's the expression? So balance less than minimum balance, okay, then 100, otherwise 0. Okay, fine. Okay, yeah, so this is how you will be having the default function. This is a function. Input are balance and minimum balance, and it returns the computed penalty amount. So by default, it is computing to 100. Okay, so this is one way you have done. Okay, of course, what additional is needed? Oh, we need the interface, the function interface called penalty, right? Okay, so here another thing which we have is when defining the interface for penalty, we have an annotation. We also have an annotation called @ functional interface. Okay, and then you can say, oh, we have this public interface called penalty, and it has the abstract method. So we have the what is the abstract method? Returns long. Name of the method is compute, and what are the parameters? Long for the balance and another long for the minimum balance. If you want, you can add other things which are like some static methods if you like. Okay, you may have a default method, but no more abstract methods, only one abstract method. Okay, fine. In an interface, default is abstract, right? So this is the abstract method of our single abstract method of our functional interface. And this is just to, it's not mandatory, but yeah, it's a good idea to always use @functional interface. Okay, so it will be doing a check whether you have a single abstract method in this or not. If it doesn't have a single abstract method and you have mentioned @functional interface, it should be a compilation error. Okay. Yeah. So, and so this is one thing which you will say, okay, let's have a penalty as an interface first, and then we have the class current account using the penalty. And of course, there's one more change which we'll have to make. What's the other change? We have already done @override, fine, where we have done the withdraw method. And how have we written the withdraw method in the current account? Takes long amount as a parameter. Yeah. So what's done in this? If this dot balance, oh, we have said this dot get balance, right, is less than oh no, sorry, oh, this dot get balance is less than amount. First check is oh, I think what we wrote was not like this, but we said if not super dot withdraw. Okay, then you return. It was saying return false. Yeah. Otherwise, what we were doing, if so, after this has been done, right, withdrawal has taken place according to the superclass. We now further carry out a check if this dot get balance is less than the minimum balance. In that case, yes, what have we got to do? We want to deduct the penalty amount also, right? Okay, balance currently is not private, it's available to me, right? So we are able to say this dot balance, and we said minus equal to, oh, we said penalty, right? No, it's a computed value. How do we compute? Is equal to compute this dot balance comma minimum balance, pass the two parameters. Okay, yeah, so that's how it is going to be used. Okay, fine. Another change in the, so fine, this change is clear, and of course there is that return true here. Right? So this part here was a fixed value, right? This was saying, okay, penalty amount. No, it's not penalty amount now. It's a computed value. Okay, based on the balance and minimum balance, maybe someone takes the difference and makes, okay, says it should be 10% of the difference. Or you could have your own implementation of the computation, how you would like it to be computed. Okay.
The penalty amount will be different every time.
penalty amount can be different now. Yes. So you have current implement that the method over there that's computing to 100 currently. So that's a default. Okay. When the object will be created of current account, the penalty which a function which it has is saying, okay, we'll give you 100. Okay, penalty is going to be 100. So in order to be able to modify that, right, we should have a method called set penalty, right? Parameter is a penalty. So here this is quite simple, right? This method is simple. Just says this dot. Right? You can change the penalty function. Through this, you should be allowed to change the penalty function. Okay, fine. See the kind of changes which we are making in the current account. Penalty, not a fixed value, but a function. Okay, so because it's now a function, our withdraw method uses that function instead of the fixed value. Okay, also provide a method to be able to change the function, set a new function to the in a particular current account object. Okay, fine. Fine. So maybe he buys a new plan or something like that. Okay, and therefore a function has been provided for. Okay, right. So this is the change which is needed for the fine. So that's a kind of change for the current account. Right? This is the current account. And then from the main method, how will it be used? You have some current account object. Okay, whatever way you may have created. Right? Constructor and everything is there. But for this, maybe after some time, you might say, okay, ca.set. Yeah, what will you use here as a parameter? You can write a lambda. You can write a lambda. You can say, okay, balance, comma, minimum balance, and write a lambda. Okay, fine. And what could that lambda be? Okay, let me have some code here. It's not as simple as just saying 100, right? Okay, yeah. So yeah, what's the code in this now? Yeah, what could be the code? It could just say, okay, let's take a long diff equals, okay, minimum balance is greater basically, and min val minus val, that's the difference. Okay. If diff is less than 0, return 0. If diff is less than 1000, okay, return 100. If diff is less than 2000, if it is less than 1000, it is going to be less than 2000. But anyway, it would have returned, right? Then return 200. Otherwise, return 500. Maybe. So you can write your own function. You decide how you want. Okay. Okay, let's say the diff is, oh, we are saying less than, right? I think if I'm saying less than 0, That would mean no, minimum balance minus balance. Okay. So minimum balance is 10,000, balance is greater than 10,000. He should be getting a penalty, so that's 0. Okay. So if this difference happens to be 700 or something, right? Okay, then it's computing it as 100. Okay, and coming out. See, that would have returned. I think, oh, yeah. 1 second. Less than 1,000. No, I think this is correct. Yeah, this is correct. Yeah. Is the penalty amount, huh? Computed penalty. This is your computed penalty. Yes. That's the value which goes in this compute, right? So he should be getting a value of 100 here, or 200 or 500, 100, 200 or 500. Okay. So from the balance, what is deducted is 100, 200 or 500. More the difference, more the penalty. Okay. So you could add more slabs to this maybe. So this is like, different slabs. Okay. If it is fine. Acha, oh, sorry. Yeah, you are correct. Less than 1,000, greater than, no, this is correct, sorry. I'm confused. हाँ हाँ ये default, right? Is it less than 1,000? Difference is less than 1,000? 100 हो जाएगा. Fine. If it is less than 2,000, it becomes 200. Otherwise, it is 500. Right? More than 2,000, it becomes 500. You write your own thing, okay? Write your own logic. And I'm showing you how you could be setting it. Now, if I do a withdrawal after this, where it is going to apply a penalty, you see what happens to the penalty. Okay. And you will be, see, the idea is to test this penalty function. Okay. So have a withdrawal, CA dot withdraw, right? CA dot withdraw. After setting up penalty, let's withdraw. And you withdraw such an amount where it should become, a penalty becomes applicable. Okay. Fine. And then see the balance. Okay. See what happens to it. Right? Fine, clear. Fine, the exercise is clear. What is to be done? Okay, fine. And think of some useful methods, if there can be any, you think you can add to the penalty. Think about some static methods, or even some static variable to be available in the static and final variable, which can be available in the penalty interface. Okay, if you feel something, yes, you can add that. And so, yeah, any questions related to the functional interface, and of course the lambda expression also. Yeah. Okay. See, there are some functional interfaces which we say as standard function interfaces which are available in the Java library also. There are some ready-made function interfaces. Okay, like we are writing a function interface called penalty, but we have as part of the Java API, Java library, there are a lot of function interfaces already available. Okay, fine. We'll be having a look at those at a later stage. And this was just to introduce what is a lambda expression. Fine. What is a function interface and what is a lambda expression? Okay. See one more thing here. Let me show another thing. Right. Normally object can be assigned anything, right? Okay. Object is something where I can assign any kind of value, right? So I can put a lambda expression here. Can I put and just say okay, okay, I want to always return 100 maybe. The one which we had earlier, balance is less than okay. Okay, something like this. Is this valid? Hmm? We think object can be assigned anything. But one thing here is when you write a lambda expression, the lambda expression does not have a type of its own. From this, you can't say for which lambda, for which function interface this is an implementation. This is implementation for which function interface. Is it penalty or is it some other function also? There could be any function interface for which this expression becomes valid. This is valid for any function interface which has a method, some method, because method name is not mentioned, right, which takes two longs and returns a long value. Okay, so this actually is not valid. To make it valid, yes, you could have done something like this. You could have said, oh, let me cast into penalty. So you can set the context. See, the type of a lambda expression is derived from the context where it is used. When you were having on the left hand side, right, as opposed to this, you were having something like this, right? Okay, we didn't need this casting. That was casting basically. But if I was having, yeah. So in that case, yes, because the left hand side has the type penalty, it derives this. The type of the lambda expression is penalty. It's for the penalty function interface. Okay, but here when you are assigning to object, no. From fine, if this casting was not done, okay, it won't know the type and this would be invalid. Okay. Okay, whereas okay, you would have to do a casting, then it is fine. Okay, so keep in mind this, that yes, the type of a lambda expression is derived from the context. Okay, lambda expressions do not have a type of their own. It always derives from its context, how it has been used. Fine. So this is the initial introduction related to the lambda expression. Fine. Functional interface and lambda expression. We have seen interface and then we have seen what is a functional interface. Fine. So any questions? Yeah. Related to this function interface or the lambda expressions.
फंक्शनल इंटरफेस में खाली हम उतना डिफाइन करते हैं ना जितना कि कंस्ट्रक्टर में डिफाइन करते हैं जो कुछ वैल्यू देनी है
ओके
ऑब्जेक्ट वाला पे
हाँ ओके सबसे पहला देखो ये क्या किया ये है फंक्शन इंटरफेस राइट सो इट विल हैव वन एब्स्ट्रैक्ट मेथड दैट इज द होल आइडिया तो ये वाला फंक्शन का इंप्लीमेंटेशन लैम्ब्डा में लिख सकते हैं see Java 8 allows us lambda expression right that means object created on the fly for implementation of a method कोई एक मेथड का इंप्लीमेंटेशन ऑन द फ्लाई बनाना है मेरे को तो वो लैम्ब्डा एक्सप्रेशन है फाइन वी डोंट हैव टू हैव अ क्लास फाइल फॉर दिस फाइन नॉर्मली कैसा लिखते हैं सी वन वे इज लैम्ब्डा एक्सप्रेशन व्हाट इज द अदर वे other way would have been okay public class okay my function 1 implements function 1 और इसके अंदर लिखते हैं @override public int some function और string s comma int a और फिर इसका इम्प्लीमेंटेशन ये वाला उठा के लिखते हैं ऐसा लिखते हैं
ये नॉर्मल हो गया
ये नॉर्मल होता है फिर इसको कंपाइल किया होता है तो इसका माई फंक्शन 1 डॉट क्लास बनता और फिर हम क्या लिखते हैं उधर जो यहाँ पे जैसे लिखा है f1 हम लोग लिखते हैं f1 इक्वल टू सो वी वुड हैव सेड function 1 f1 equals new my function 1 और उसके अंदर डिफॉल्ट कंस्ट्रक्टर हो जाता है उसका ठीक and then we would have said f1 dot for some function right so function f1 equal to we were doing like this earlier बराबर है यहाँ बोलता है ठीक है ऐसा ही लिख दो सीधा वो जो तुमको लिखना है ये सब ओवरराइड करना है सम फंक्शन का लिख रहा हो वो छोड़ दो हाँ दिस इज इजी हाँ तो अब ये कर सकते हैं पहले ऐसा करते थे earlier this is what was done but now we can do it like this right और फिर आगे जाके फिर से चेंज करना f1 इक्वल टू तो कर दिया अलग अलग क्लास बनाना नहीं पड़ेगा right because there are multiple implementations of that some function का अलग अलग implementation लिखना है तो लिखो जहां चाहिए वहां जैसा यूज करना है कर लो fine see what we have done वो एग्जांपल में set penalty fine set penalty method is there penalty पास करना है अलग अलग फंक्शन पास करो अलग टाइम पे fine clear no separate class file to be created fine a synthetic class है ना वो चेक करा था हमने कैसा है वो ओके